beginning of calculus, everyone knows it is limits. And the limits, what we are learning in your 11th and 12th level is all basics and applications. You can see I have collected many images for your purpose. Many applications are there, and the beginning is limits, and after that, you know, the continuity and discontinuity of a function, and then differentiability, non-differentiability, and after that, the derivatives and the applications of derivatives. This is what we know in differential calculus. But in the beginning, what I'd like to do in the limits is that let me revise the formula, what you have learned. At a glance, we will see that, and then we will move on to working out the problems, because it is advanced level questions. Whatever you have learned in your board level and JEE main level, let us revise them. Let us revise them. Just a moment, please. I'm sharing my screen. Yeah.
Sir, you had sent some homework. Sir, I have doubt in that.
Yeah, I'll go to that in between.
Yes, sir.
So, if you see the limits, and basically what is that, you have to understand the existence of the limit. Limit exists only when its left-handed limit and right-hand limit are equal. Just I'm not going into more details of it. Just I'm giving you the random revision of what we have learned. Okay, so if you see, the definition, existence of the limit is important. Existence. So limit exists only when the left-handed limit is equal to right-handed limit. Everyone knows that. I need not have to tell you that. Left-handed limit is equal to right-handed limit. So limit of f of x as x tends to a minus is equal to limit of f of x as x tends to a plus. Then only the limit exists. Otherwise, we say that the limit does not exist. Now, let me revise an example based on this. Example, limit of mod x by x as x tends to 0. This is very clear. The left-hand limit is equal to limit of mod x by x as x tends to 0 minus, this becomes minus x because it is tending to negative 0, minus x by x, and it is minus 1. Similarly, if you take right-hand limit, obviously the right-hand limit will be plus 1. You can also respond. You can also respond what I am saying. Limit of mod x upon x as x tends to 0 plus. That is 0 plus means it is plus x, positive 0. Positive 0, that is x by x 1. So here left-hand limit is not equal to right-hand limit. Left-hand limit is not equal to right-hand limit. Therefore, you can say that comfortably that the limit does not exist at x is equal to 0. The limit does not exist at x is equal to 0. So, I have taken an example. Therefore, limit of mod x by x as x tends to 0 does not exist. But if you see this graphically, it is a signum function. We represent this with signum x. Signum x is nothing but mod x by x will have only three values: -1, 0, 1. So if you draw this, if you want to show this graphically, x-axis, y-axis, and for all positive values, it is +1. For all negative values, it is -1. And at 0, it is defined to be 0. At 0, it is defined to be 0. So this is like this. This is at 0, it is defined to be 0. And if it is plus x, it will be only 1. If it is minus x, it will be only -1. That means you have to understand, for a positive 0, it is becoming 1. For negative 0, it is becoming -1. And hence, the limit is not existing. So this is +1, this is -1, and this is 0. So for +1, you are getting 1, that is positive 0, you are getting 1, and negative 0, you are getting -1. And hence, the limit does not exist. This is what you have to understand with respect to non-existence of the limits. And in general, what is the mistake attempted by the students is this. I'll show you that. Where you forget writing the modulus whenever you get any term out of the square root. For example, if I take limit of root over limit of root over 1 minus cos square x whole divided by x as x tends to 0.
Not defined.
So generally what you do, you write it as sin x, and sin x by x as x tends to 0, you write it as 1, but
Mod sin x.
Modulus must be written. If you forget this, you think that you did it right, but it goes wrong. It goes wrong. That is the reason why you must take care while working out the problems related to the square root. Related to the square root. In this case, your LHL left-hand limit becomes x tends to 0 minus means sin x. Sine of negative quantity becomes minus sin x. So this is -1, and RHL becomes +1. Therefore, in this case, limit does not exist. Remember to write this modulus here. Similarly, in case of step functions also, generally the mistakes are attempted by the students. Even for the step functions, step function is continuous at all non-integral values and discontinuous at all integral values. So this is what the existence or non-existence of the limit. And let me revise the formula faster so that we'll move on to the problems. Just a moment, please. Now this is let us check it out. One moment, please. Yeah. Just moment. Not able to see my desktop. Oh, what happened? Let me check once. Mm, yeah, it's there. Now, let me randomly let us revise all the concepts. The first what I discussed is the existence of the limit, and I have explained if the left-handed limit is equal to right-handed limit, then we say that the limit exists, otherwise limit does not exist. So this is the basic thing everyone knows, and you know the indeterminate forms, so 0 by 0, infinity by infinity, and infinity minus infinity, infinity into infinity, 0 into infinity, 1 power infinity, 0 power 0, infinity power 0. These are all said to be indeterminate forms. These are all said to be indeterminate forms. For these indeterminate forms only, we will be applying the concepts of limits. For all the remaining forms, you can straight away write the answer. For all the remaining forms, you can straight away write the answer. For example, if you are given something like limit of x upon x plus 1 as x tends to 0 given, then what is that you write? You write 0 directly. You need not to simplify that. Similarly, limit of x divided by same, let me take x plus 1 as x tends to infinity is given, then you cannot write that this is in the form of infinity by infinity. Then you have to apply the concepts of limits. Understand that. Whenever the limit is directly existing, you can straight away write that. You can straight away write that value. No confusion, please. Similarly, so wherever you get these indeterminate forms, wherever you get
So
this
the
indeterminate,
teacher is
we have to make use of the limits. Okay. Now, someone saying, who is it?
नहीं नहीं सर अभी स्क्रीन शेयर नहीं देख रहा था सर आपका
Huh. No, you don't see my screenshot screen. Okay.
नो सर हाँ सर अभी देख रहा हूँ
अब देखो आ रहा है ना?
Yes, sir.
Yeah. At least he reminding people are sleeping, just listening me. So मैं तो explain कर रहा था. ठीक है. तो left-handed, right-handed limit I have already explained. I need not have to give you more explanation about that. If both are equal, then only limit exists. Similarly, coming to the indeterminate forms are 0 by 0, infinity by infinity, infinity minus infinity, infinity into infinity, 0 into infinity, 1 power infinity, 0 power 0, infinity power 0. And all these are said to be indeterminate forms. So wherever you get these forms, wherever you have to apply the concepts of limits. So totally you can see 1, 2, 3, 4, 5, 6, 7, 8, 8 indeterminate forms are there. So now these are all categorized for the purpose of working, and I'll explain you that. Now these are indeterminate forms. Whenever you get, then you make use of the concepts of limits. Otherwise, there is no problem in straight away writing the limit. For example, that's what I've been explaining you. I did not share my screen. Now It is visible now. So limit of x upon x plus 1 is there, as x tends to 0 is there. No need to think about this. This 0 by 1, 0, that's it. Similarly, limit of x upon x plus 1 is there, as x tends to infinity is there. Then you should not apply, because it takes infinity by infinity form. Then we apply the concepts of limits. This is what you have to understand. So wherever straight question is given with the existence of the limit, then you can straight away substitute it. Next, coming to sandwich theorem. Sandwich theorem, you know, the extremities or left-handed function and extreme right-handed function limits will be existing. You know the shape of the sandwich, and above and below there will be bun, and in between you will have some stuff there. Similarly, here in this case, what happens? This is a function whose limit is not known to us, which is g of x. Then in this condition, what we do, if we apply limit to this one, limit of f of x as x tends to a is less than or equal to limit of g of x as x tends to a is less than or equal to limit of h of x as x tends to a, then g of x is lying between f of x and g of x, then it also takes the limit value of fx and hx. Limit value of fx and hx. This is nothing but the sandwich theorem. Wherever it comes, we'll be discussing that. Okay. So graphical, if you want to see, it is like this. It is like this. It is like this. This is, I'll draw it. Just a moment. This is one function, and this is another function. You have one more function in between. Then the limit of this function, wherever the common point is there, wherever the common point is there. Wherever the common point is there, if you want this one as y is equal to f of x. This one is y is equal to h of x. And this one is y is equal to g of x. It is clear that at a particular point, for example, if you take something like x is equal to a, if you take this, x is equal to a, then what is that we do? At x equal to a, if you want to understand the limit of g of x, then we write it like this. F of x is smaller and h of x is greater and g of x is in between. Then in that case, we write fx less than or equal to g of x less than or equal to h of x. So equality is possible at this point. Then we apply the limit of f of x as x tends to a less than or equal to limit of g of x as x tends to a is less than or equal to limit of h of x as x tends to a. If its value is something like L, let me say, its value is something like L and it is also L, then it takes the value L. That's what it is. This is nothing but the sandwich theorem. Wherever it comes, you can comfortably apply this sandwich theorem. Okay. So now, this is what the sandwich theorem is. The problems these are all only theory part I'm just revising. We are not going to see the problems there, and we have separate worksheet for the problems. Fundamental theorems on limit, I need not to explain you this because whenever addition and subtraction and multiplication are there, you can straight away apply the limits individually, even in the division also. And limit of log of f of x, you can send the limit inside. Limit of log of limit is one and the same. So, and one more important point you may come across in the advanced level problems is that limit of f of x is less than or equal to x tends to a is less than or equal to limit of g of x as x tends to a. If f of x is less than or equal to g of x, whatever the inequality is there without limit, whatever the inequality is there without the limit, that inequality continues even after the application of limit. Even after the continuation, it will continue even after the application of limit. This is what you have to understand. Now, similarly, here limit of f of x whole power p by q, and apply limit to this one. P by q is a constant, and its limit is L, then it is L power p by q. These are all the basics you know. Now, these important expansions are given. And in the advanced level, particularly, the problems will be solved based on the expansions. You will have to solve the problems based on expansions. So, it is inevitable that you have to remember that. You have to remember that. But I'll give you a technique for this, which you will be getting further in your engineering studies. The higher level mathematics contains an expansion which backs off all the expansions into a single expansion. These are all to be remembered. Tan x, cos hx, hyperbolics, you leave it. Hyperbolics is not in the syllabus. Sine inverse x, tan inverse x, cos inverse x, and sine x, cos x. This binomial expansion, 1 plus x whole power 1 by x log of 1 minus x, e power x, a power x log of 1 plus x and all this. Okay, these are the expansions to be remembered. For this one, I have taken a short form for you to remember or to reproduce all these expansions only from one expansion, which is known to be Maclaurin series. What is it, Maclaurin series? Let us see that. This is called Maclaurin series. Whatever the function is there. Dhananjay, can you read this once?
Yes, sir. F of x is equal to f of 0 upon 0 factorial plus f dash 0 into x upon 1 factorial plus f double dash 0 into x square by 2 factorial plus f triple dash 0 into x cube by 3
And
factorial
so on,
plus
and so on,
f,
and so on,
yeah,
and so on. So this gives you the expansion of whatever the function you take. Fx is the function. First term will be f of 0 by 0 factorial. Second term will be f dash 0 by x by 1 factorial into x by 1 factorial. Third term will be f double dash 0 into x square by 2 factorial. Most generally, the first three terms are needed in any expansion, not all. Not all. A maximum it may go to up to the fourth term. Maximum it may go up to fourth term. So what is fx here? Remember this. And if you are really serious about the advanced IIT-JEE advanced, take a screenshot of it and save this expansion. And of course, you'll be getting again in your engineering, but we are using it here to reproduce all those expansions and not to by heart them. But if you have good memory, that is always an advantage. If you have good memory, there's always an advantage, no doubt in that one. But in any case, if you forget, no, then we have to make use of this. So fx is equal to f of 0 by 0 factorial plus f dash 0 by x into x by 1 factorial. You can see this one, it is clear, x power 1 and factorial 1 and the first derivative. Second derivative, power 2, 2 factorial. Third derivative, power 3, 3 factorial. This is what you have to understand. Now, if I say like this, you may not be getting the clear picture of the working. So let me take an expansion and prove it. See, this one, this is in the packed form, that is in the summation notation. Notation is fx is equal to sigma nth derivative of f of 0 divided by n factorial into x power n. This is it can be easily remembered because whatever the derivative order is there. That will be the power of x, and that will be the factorial. And it runs from 0 to infinity. Okay. Now, let me explain you that. Let me explain you. I'll take an example and explain so that wherever it is used, there you can comfortably apply this. Okay, just see this. Now, let me take sin x, please. Sin x, everyone knows that, but I'm taking it for. Now, our sin x is fx here. Just follow this carefully, please. Our fx is sin x here. Now, let me write Maclaurin series. Let me write Maclaurin series fx now can be written as f dash 0, f of 0, first derivative, first one is f of 0 plus, is it correct or not? Just I'm showing it again. F of 0 by 0 factorial. Anyway, that becomes 0 factorial 1 only. That's why I did not write that. F of 0 by 0 factorial plus f dash 0 by 1 factorial into x power 1 plus f double dash 0 in divided by 2 factorial into x square. Order is same. Plus f triple dash 0 by 3 factorial into x cube and so on up to infinity. This is nothing but the Maclaurin series. Now we are going to apply this. We are going to apply this Maclaurin series for sin x. Okay, just follow this. Now we'll have mind calculation for this. We'll have mind calculation. What is the derivative of what is sine 0? First term to write. What is sine 0, please? 0. So you will not have first term. That is eliminated. What is the derivative of sine x? Cos x. Cos 0, 1. 1 by 1 factorial, 1. I'm talking about this. 1 by 1 factorial, 1. 1 into x. Now, first derivative is cos x and second derivative is minus sin x. Sin 0 will be always 0 and hence this term will be eliminated. So sin x derivative, cos x, and cos x derivative, minus sin x derivative, please. Minus cos x and minus cos 0, 1. So minus 1 by 3 factorial into x cube plus and so on like this. So your sin x expansion is nothing but x minus x cube by 3 factorial plus x power 5 by 5 factorial. Not more than that is needed as per our requirement. Similarly, cos x can also be found out. Similarly, e power x can also be found out. If you want e power x is important expansion, I'm doing that. E power x, e power 0, 1. E power x derivative, e power x. So f dash of 0 means e power 0, again 1. 1 by 1 factorial, that is x by 1 factorial. Next, every derivative of e power x is 1 only. So this all f of 0, f dash 0, f double dash 0, f triple dash 0 all become 1, and hence this expansion will be x square by 2 factorial plus x cube by 3 factorial plus and so on up to infinity. Like this it goes. This is nothing but remembering the expansions for the purpose of solving the limits is like this. This is nothing but Maclaurin series. Okay.
Yes, sir.
And you can pack off all those formula into single formula like this. Okay. For your purpose, I have collected this. And now let us move on to the next part of it. This is about the expansions, please. This is about the expansions. Now, Every expansion can be derived from that one. Okay. Methods of evaluation of limits, algebraic limits, direct substitution method. Just we are giving a random look at all the methods, algebraic limits, direct substitution method. That's what I said in the beginning. Direct substitution method means if there is no indeterminate form, you can straight away do that. Factorization method, and by factorization, if the factor is getting cancelled, whatever for whatever the value the limit is not existing, or whatever the value the limit is taking indeterminate form, if that value is getting cancelled through factorization, then we have to follow the factorization method. Next is rationalization method. I need not to explain you that. Through rationalization also, the that particular value of x can be cancelled off based on the form of x tends to infinity. This is all we can do that. And if the limit is x is tending to infinity, then we write 1 by x tends to 0. So whenever x tends to infinity problems are there, we have to convert them to 1 by x form. 1 by x form. Okay. So limit of 1 by x power n as x tends to infinity is always 0, because 1 divided by infinity becomes 0. And one more important point, frequently what we get, particularly in the limits, is that if mod r is less than 1, then r power n tends to infinity as, just moment, I wrote wrong there. R power n tends to 0 as n tends to infinity. R power n tends to 0 as n tends to infinity. This is frequently to be used. Similarly, if mod r is greater than 1, then r power n tends to infinity as n tends to infinity. There is no use at all in the second case, because when the tending to infinity case will not be changed in this case, will not be changed, but it becomes a 0. So in solving all the infinity problems, infinity, the limits related to infinity, we have to make use of this. What does it mean? Mod r less than 1 means r value lies between -1 and +1. R value lies between -1 and +1. Why it tends to 0? And I discussed, I think you might have learned this. 0.1 whole power 1 becomes 0.1, and 0.1 whole square becomes 0.01, and 0.1 whole cube becomes 0.001, and 0.1 whole power 4 becomes 0.0001. And if it extends to some 0.1 power 100, what happens? After decimal, you will get 99 zeros and then 1. Oh, that's what it is. The power is tending to, as the power is tending to infinity, or power is getting raised, what is that happening? The value is getting to 0. The value is tending to 0. You have to make use of this property, please. You have to make use of this property. So whenever the base is not lying between, I repeat, whenever the base is not lying between -1 +1, then you have to forcibly bring this base. You have to forcibly bring this base to lie between -1 +1. What is the advantage by bringing it like that? The advantage will be that as n tends to infinity, when the base is lying between -1 +1, it tends to 0, and thereby you can solve the limit. You can solve the limit. This point is to be noticed. Okay. Next is, this is what just now I said, and this is also an important form which is to be remembered and even frequently used in the question, the infinite limits case. Infinite limits. Just for the revision sake, if m is equal to n, if the power degree of the numerator expression and the denominator algebraic expression are same, then the answer will be A naught by B naught. Just say this. If the denominator has more degree of the denominator is more than the degree of the numerator, then it becomes 0. If it is the degree of the numerator is greater than the degree of the denominator, then it is infinity. Then it is infinity. I hope everyone remember this. Respond, please.
Yes.
Yes,
Yes,
sir.
sir.
So I need not to take any example on this one.
No, sir.
No, sir.
So now coming to different categories of solving the problems in limits. What I mean to say by category, we have seen some 8 indeterminate forms there, and getting to those 8 indeterminate forms, they are categorized in methods in solving the limits. They are categorized like this. Let me show you that. Now, I need not have to tell you all this, just you have to revise this. Limit sine x by x as x tends to 0, 1, even its reciprocal is also same. Limit tan x by x as x tends to 0 is equal to 1, even its reciprocal is also 1. Similarly, sine inverse x by x under the limit x tends to 0, 1, even its reciprocal also same. Limit of tan inverse x by x as x tends to 0, 1, even its reciprocal also same. And you have to recognize, you have to recognize the difference between these two. This is x degrees is given. Here you are given x. When degrees is given, this limit is valid only when it is in radians. When it is in radians, though you have to convert these degrees to radians, and then only you can solve the limit. That is the reason why instead of 1 you get pi by 180. Remember that. Similarly, what all the important limits are there? That's it. And find the difference here. This one also, limit of sine 1 by x upon 1 by x as x tends to infinity. 1 by x means it is 1 by infinity 0. It is again in the form of sine 0 by 0, 0 by 0 form, and hence it also becomes 1. Here it is x by x. It is sine x by x. X tends to 0. It is sine of 1 by x by 1 by x as x tends to infinity. Okay. Now, let us move on to the next part of it. This is one part of the formula, and whatever. This is what generally the students go wrong or attempt the question wrong in a wrong way, because there is a root and you forget to write the root and you forget to write the modulus. So root over 1 minus cos 2a is mod sine x minus whole divided by x minus. Another limit x tends to 1. Here, the limit does not exist. For 1 minus, the limit is minus 1. For 1 plus, limit is plus 1. And of course, I have not written this root 2 here. Under root, it becomes 2 sine square a. 1 minus cos 2a, 2 sine square a. So that root is there. So one is plus root, the other one is minus root. The limit does not exist. So in the ground realities, you must be careful, even though you are learning the concepts. And in the ground reality means whenever you are working out the problems, you must get that idea of applying these concepts without forgetting. Without forgetting this concept, you must be in a position to apply this. Now, logarithmic limits, log of 1 plus x. Just now I said how to write the log of 1 plus x as a function, and how to write its expansion using Maclaurin series. Using Maclaurin series also, you can remember this, you can derive this, because we may not need more than 2-3 terms. First 3 terms only we will need in the problems. Okay, so that's the reason why it's not that difficult to derive this expansion. If you remember it, that is great. If you remember it, that is great. Just remember, because Indians are good in remembering and in by hearting, and compared to the other people of the world. So you can also do that. Say log of 1 plus x means it is a function, and if you put x is 0, that is 1 log 1 0, so that's why no term here. And if you take the first derivative 1 upon 1 plus x, 1 upon 1 plus x, if you put x is equal to 0, that becomes 1, so 1 into x by 1 factorial x. So 1 upon 1 plus x derivative again, you will get the second term. Like that it is. Now this is a logarithmic expansion, and you can make use of this formula. You may be getting this frequently, and how this is to be remembered and how it is got, you know, that this 1 by x will be taken away to the power, then this becomes log of 1 plus x whole power 1 by x, whole power 1 by x. That becomes e log e to the base e becomes 1. And of course we will be getting problems on this one. Then we will discuss this again. Okay, next, that is the logarithmic limit. So what is that logarithmic limit? You have to remember. Let me write that once. Limit of ln of 1 plus x upon x as x tends to 0 is equal to 1. Is equal to 1. Remember that, please. Now, exponential limits. Exponential limit. Just now I derived e power x expansion, you know that. And in this one, this is also important, and you will be getting these problems, this formula application in the problems. Limit of e power x minus 1 by x as x tends to 0, 1, and this is a main formula, because limit of a power x minus 1 by x as x tends to 0 is log a to the base e. If you replace a with e, that becomes 1. If you replace a with e, that becomes 1 only. So this is a main formula. Limit of a power x minus 1 upon x as x tends to 0 is equal to log a to the base e. And in the problems, if you get something like e power lambda x minus 1, then we multiply with lambda and divide with lambda. That becomes lambda then. That becomes lambda. Okay? Similarly, the important part of limits is that applying the L'Hopital's rule for 0 by 0 form and infinity by infinity form. This is limited only to 0 by 0 and infinity by infinity forms only. And of course, it can be applied even to 0 into infinity form also, provided you convert this as 0 into 1 by 0. Then it can be applied. But you cannot apply this directly to 0 into infinity form. So what is that L'Hopital's rule? I need not have to explain it, that we differentiate the numerator and denominator separately, and we substitute the limit if it is not taking 0 by 0 form or infinity by infinity form, we take the limit value, or otherwise we go for the further derivatives. So we get we have to differentiate till we get this removal of 0 by 0 or infinity by infinity. Okay, that's what is the L'Hopital's rule. Okay, now next is the exponentials. Exponentials is exponentials is 1 power infinity form, and infinity power 0 form, and all this comes under exponentials. And you have to remember the Leibniz rule also in this case, please. 12కి అపాయింట్మెంట్ అక్కడ ఇక్కడే సనత్ నగర్లో 12కి వెళ్తే అది బహుశా ఆయన ఇల్లు అనుకుంటా. అందుకని చెప్పి ఆయన ఆ పార్టీని పిలుస్తున్నాడు. ఇల్లు నాకు తెలియదు, ఏదో ప్లేస్ అనుకున్నా. 12ంటికి వెళ్ళాలి అంటే ఆడు మళ్ళీ ఆ భోజనం అన్ని ఇబ్బంది పెడతాడు నాకు. అందుకని ఇక్కడి నుంచి నేను కనీసం 11:30 బయలుదేరి కూర్చు. 11:30 లోపు నాకు అన్నం పెట్టు, అది నేను చెప్పి. Anyone, do you remember Leibniz rule?
Yes, sir. A
F of upper limit into
derivative of that function and minus lower limit into derivative of that function.
Correct. Good. Yeah. For the purpose of reminding people, let me write that. Just if you visualize it, it will be very good. Derivative of integral of L of x, U of x. Symbolically, I'm taking lower limit, upper limit. F of t dt. Particularly in the higher level problems, the usage of this formula is there. You must be getting this in integration. So, f of u of x into u dash x minus f of L of x into L dash x. This is Leibniz rule, please. Okay. Visualize this. Visualize this. Upper limit substituted in the function into its derivative minus lower limit substituted in the function and its derivative. That's it. Okay. Now, finally, you have, this, I think this sheet is finished here. Let me go for the second sheet. Just a moment, please. Let me open the other sheet. And even I'm closing this also. McLaren series, everyone, those who are interested, take a screenshot of it.
हाँ सर ले लिया था.
Good boy. Now, one moment, please. One moment. Yeah, it is done. Yeah. So this is assignment. Okay. So they have not concentrated on this. Yeah, anyway, I'll revise it. I'll revise it. Just a moment, please. Yeah. Now, wherever you get 1 power infinity form, particularly 1 power infinity form, particularly, then what is to be done? You have to apply logarithm and you have to get it to the form of 0 into infinity, and thereby you can apply L'Hospital's rules. I'm not doing all this, but I'm just reminding you the method of applying this, method of solving it, limit of f of x whole power g of x as x tends to a takes the form of 1 power infinity, takes the form of 1 power infinity.
E raised to f of x minus 1 into g of x.
Correct. Correct. Then it will be e power limit of g of x into f of x minus 1. It is simple only, like we will be applying the concept, we'll be applying logarithm on both sides, and we can get it easily. We take it as some I and For L, we apply logarithm, log L to the base E. Then this will become g of x into f of x. And then we finally, after simplification, we finally remove the logarithm. And you will get this form. Remember that. So applying logarithm is the method to be remembered in case of this exponentials. Applying logarithm is the method to solve the problems that are related to exponential problems. Okay. Now let us start doing the problems. Simple question, limit of x power 7 plus a power 7 divided by x plus a as x tends to minus a, is equal to 7. Then the value of a is, you know the formula, but you can straight away apply L'Hospital's rule in this case because it is an objective question. You can do that easily. And what happens if you apply the L'Hospital's rule within one step, you can get the answer. The denominator becomes 1. And the numerator 7x power 6 as x tends to minus a is given to be 7. So that 7 gets cancelled and you will have straight away x power 6 is equal to x power, replace x with minus a, and thereby you will get a power 6 is equal to 1. And a cube is equal to
A and B.
a and b. That's it. So it is a simple problem, and even if you don't know, even if you don't remember the derivative method, that is L'Hospital's rule, also you can do this. A, B. Like what? Which is the formula to be used here? This is limit of x power n minus a power n upon x minus a as x tends to a is equal to, anyone please? N into a power n minus. That's it, please. You can make use of this. Yes, it is done. Next question, please. Just see that every one of you, limit of greatest integer of modulus of sine inverse of mod x divided by x. Whenever step function and modulus are there, it is inevitable that you have to find out left-hand derivative and right-hand derivative. And you may be thinking, sir, where to apply left-hand derivative and right-hand derivative, and where not to? Where not to? In the previous stage, we have not applied that. Just observe that. In the previous problem, we have not taken the left-hand derivative, right-hand derivative separately because most generally for all the polynomials, rational polynomial functions or expressions, we don't take left-hand derivative and right-hand left-hand limit and right-hand limit. But in case of greatest integer function and modulus, we'll have to. Now I am writing LHL here. LHL means x tends to 0 minus. This is limit of step of x tends to 0 minus means this becomes minus x modulus of minus sine inverse x. I'm talking only about x here. Whole divided by x as x tends to 0 minus Because it is tending to 0 minus, I made this mod x as minus x and I brought this minus to out of the inverse. Sine inverse of minus x. If you want me to write, I'll write that clearly. Are you there, everyone?
Yes, sir.
Now, in the next step, if you want to remove the modulus, you must be confirmed with that. It takes the if you want to remove the modulus, final result after removal of modulus must always be positive. You should not forget that. So x tends to 0 minus. But before that, you must know the range of sine inverse.
-1 to +1.
Minus pi by 2 to pi
That
by
is a
2.
confusion, Dhananjay.
Oh, range.
You are talking about
Domain.
domain, of
About
course,
of
and
sin x.
there is a confusion. That's what
I'm
I'm saying.
talking about sin
You're
x.
talking about sin x. Okay. Now what happens?
It will be negative. We are approaching from negative side. The sin inverse x will also be negative.
Huh. So what happens here then?
Minus of minus.
Minus sin x. Minus sin x upon x.
Divided by x as x tends to 0 minus. Okay. Then it will be tending to -1 plus, and hence its answer will be -2, please. It is to be understood, please. It is to be understood carefully. Let me finish this and we will discuss it again. RHL. Limit of. Come on, tell me anyone.
Sin inverse x only.
By x as x tends to 0 plus. Then obviously it becomes positive. Correct now? You can remove the modulus. It will be 1. I have shown you the formula, please. I have shown you the formula. Limit sin inverse x by x as x is 0 is also, its value is 1. So, according to this, what should be our options? Let us check it out. Left-hand derivative, left-hand limit is -2, and left-hand limit is not -1. Right-hand limit is 1. So, this is correct. A and C must be correct, please.
Sir, how is left hand limit -2 -1 होना चाहिए?
Next 0 minus है तो sin inverse x का वैल्यू नेगेटिव हो जाएगा.
Yes.
And it approaches minus pi by 2. Let me write
Yes.
the approximate value of minus pi by 2.
-1.57.
हाँ वही है. आप समझ गया ना?
हाँ हाँ अब समझा. Thank you sir.
what the question asked by Parsh is a valid question. ये तो माइनस 1 point something हो जाएगा. This approximate value anyway. So that's the reason why it becomes minus 2. I think it's clear. Everyone, please.
So, but they have told us that it is tending to 0 from the negative side. So it should be minus
it
1.
it
So
should
it should be minus 1, sir. And right hand limit 0 आना चाहिए और left hand limit minus 1 आना चाहिए.
नहीं.
नहीं सर, मुझे अभी भी नहीं समझा क्योंकि साइन इनवर्स एक्स बाय एक्स का अपॉन एक्स भी है ना वो.
वही सर.
हमने सिर्फ
Sir,
साइन इनवर्स एक्स का ले लिया.
And so for very small x, वो सर ग्राफ में भी sin x और x का ग्राफ like for very small x converge ही होता है almost. So for very small x we assume that sin x is equal to x.
नहीं, आप
तो
फिजिक्स
sin
के
inverse of x भी x ही
आप
होगा ना
फिजिक्स की
सर.
बात मत करना इधर. हाँ, एक मिनट में
अरे
ग्राफ दिखाऊंगा. ग्राफ दिखाऊंगा. एक बार let me check the answer also. One moment. Where is it written? Just moment. अच्छा, ये भी AC है इधर. AC है. So if my logic is correct, the answer is correct. Let me show you the graph of it. Just a moment, please. Let me show you the graph of it. See, what happens if you take the graph of sin x between minus pi by 2 plus pi by 2, this is like this. This of course 0, and it will go like this. And one more thing we have to always, while making the graphs of inverses, it is better you always take the line y is equal to x. The line y is equal to x, please. Just a moment. Why should we take y is equal to x, please? It acts as the mirror, please. It acts as the mirror. Yeah. It acts as the mirror. Little more extension is needed. Just a moment. Always remember while drawing the inverse graph, take y is equal to x line because it is the mirror. Now, if you draw sin x graph, sin x graph, sine of minus pi by 2 minus 1, and cos of pi by 2 plus 1. This is whether it goes up or down, that is also important here. Y is equal to x is such a line, it will have all x coordinate, y coordinates equal. What is the approximate value of pi by 2? Just now we have seen 3.14 by 4, no, by 2, no?
1.07.
1.57.
57.
That means this will go above the line. That means it will come below the line, and it intersect at the line at 1 somewhere here. This point lies, it should be 1 comma 1. Just follow this, what I'm saying, please. Similarly, you will have minus 1 comma minus 1. This is somewhere minus 1 comma 1. Something like this. Then let me draw this graph, please. Let me draw this graph. So it will be like this. Not exactly, but some part of it will be above the line and some part of it will be below the line. There is little correction here. Little correction. What is that correction? Just you have to show it increasing downwards. This is what? Sin x graph, please. Sin x graph. Why I have taken y is equal to sin x here? Now it is easy to draw sin inverse x. This is somewhere pi by 2. Range, please. This is somewhere minus pi by 2. Now draw the just mirror image of it. This will go like this. This will be the mirror image. This will be the mirror image in this way. Now let us discuss. The graph, what we need is in the green color now. This is what the graph is. The graph which we need is in the green color now. Yeah, Dhananjay.
we need sine inverse of x का ग्राफ आंसर मैंने देखो ना मैंने आपको चैट पे स्क्रीनशॉट भेजा है सर वो ग्राफ का
ये sin और x का ही है ना ये? नहीं क्या?
नहीं सर सो साइन इनवर्स x का और y इज इक्वल टू x का ग्राफ ऐसे नहीं जाएगा
सर बराबर है
It's not properly. We are not getting it. Just a moment. It's done. हाँ, ये है बेटा.
सर एक बार आप चैट चेक करना सर मैं आपको स्क्रीनशॉट भेजा है सर चैट में
एक मिनट चेक करो. एक मिनट धनंजय. I'll check it out. So 0 plus 0 minus. Sin inverse x by x. And इसका step value. Limit of step of sin inverse x by x as x tends to 0. Exist or does not exist? Anyone, please.
exists sir
Anyone in the class?
it does exist
Does not exist or exist?
does exist
वेद नहीं है क्लास में. Parsh, do you tell me whether this limit exists or not?
It exists.
Don't forget that these brackets represent GIF.
Yes, sir.
This is GIF, please.
does not exist
Sir, हाँ does not exist होगा हाँ
तो
sorry.
क्या बोल रहे हैं यार आप लोग?
और अगर x टेंड्स टू 0 नहीं होगा बट x टेंड्स टू 0 प्लस और 0 माइनस करेगा
हाँ
हाँ बोलो. बोलो ना. First of all, it does not exist.
हाँ सर
और प्रॉब्लम पे जाएंगे. Does not exist means definitely the left hand limit is different from
right hand
right hand limit. There's a point to be confirmed. Yeah. अब इधर क्या दिया? x tends to 0 मॉड्यूलस ऑफ sin इनवर्स ऑफ mod x by x. तो mod x का x ग्रेटर देन 0 है तो वो प्रॉब्लम नहीं है. mod sin इनवर्स x हो जाएगा डिवाइडेड बाय x. तो what I said, because it is minus pi by 2 to plus pi by 2 value, the lower limit is minus pi by 2 and the upper limit is plus pi by 2, the range of it. So, for example, if you take, I'm talking to Parshva now. Parsh,
Yes, sir.
for example, if I take the greatest integer function in this limits,
-2 to 1.
हाँ, greatest integer of, again, this is a big brackets, gives you the greatest integer of this will be, this is -1 point something means you will get -2, -1, 0. Obviously 0 will be there, isn't it?
Yes, 0 will be there. And 1.
And 1. This should be the step value of this. Don't forget that. This should be the step value of this sine inverse x. Okay, because it is its range. Now, of course, what you are saying is by x is given. Correct or not? Divided by
Yes.
x is given. That x is tending to 0. If x is tending to 0 minus, what will be sine inverse of 0 minus? This is what you have to tell me.
It will tend to 0 from negative side. So negative होगा.
Minus sine inverse 0. Correct or not?
हाँ.
Minus sine inverse 0 means it will be minus negative side of 0 it goes. Divided by x is there. Isn't it? Divided by x is there, of course. Divided by x is there. That means, what is the value of, just a moment, please. What is the value of sine inverse x by x as x tends to 0, please? 1. So it goes on -1 side.
So that's why it's -2.
It goes on -1 side. That is why it becomes -2, please.
हाँ सर, अब समझा A और C कैसा है. Correct.
And let me check once the Dhananjay graph. Dhananjay Babu, कुछ chat box में दिया बोल रहे हैं. एक बार डाउनलोड करेंगे. कहाँ आया ये? क्विक एक्सेस क्या है यार? ठीक है, डेस्कटॉप पे कर देंगे. कर दिया. ओपन फाइल. फाइंड इन फोल्डर. ओपन फाइल नहीं आ रहा है इधर. एक मिनट. कहाँ है?
सर उसने डेस्मॉस यूज करके डाल
क्या
दिया.
बेटा?
सर उसने डेस्मॉस यूज किया, मतलब इधर से डाला.
नहीं, क्या है इधर डेस्कटॉप पे नहीं दिख रहा है यार. क्यों ओपन फाइल क्यों नहीं आ रहा आगे? ये क्या? ओ ओ ओ ओ एक मिनट. Another program is currently using this file. क्या भेजा यार? एक मिनट. इधर नहीं है. कहाँ पे ये? इधर ओपन हो गया यार. कहाँ पे धनंजय? Where is it?
वही स्क्रीनशॉट है.
हाँ, अच्छा ये है.
हाँ.
वही है ना वो.
तो मैं यही बोल रहा था कि as it tends to 0, तो sine inverse of x and x is almost equal.
नहीं, वो तो अलग है यार. इधर sin इनवर्स x by x अभी जो मैं एक्सप्लेन किया ना,
हाँ.
वो देखिए आप समझ लो. ठीक है? We are taking more time for this. let me go back. Yeah. Now, the next question, please. So that's done. Next one, please. प्रथमेश है क्लास में? जहान, लोग लेट आए आज.
यस सर.
लेट आए ना बेटा?
नहीं, मैं पहले था, फिर फोन बीच में बंद हो गया था, तो
अच्छा,
फिर वापस ज्वाइन हुआ
ठीक
थोड़ा
है.
टाइम बाद.
If P is less than Q, अभी जो मैं फॉर्मूला दिखाया उसकी वजह से आप आंसर डायरेक्टली बता सकते हैं. P,
स्टैंडर्ड रिजल्ट ABC.
P less than Q means degree is less than it is A is correct, and is equal to 1 if P is equal to Q, correct. Infinity if P is correct is equal to 1 if P
Correct.
greater than Q, galat. So
Wrong.
what are the answers?
A, B,
A,
and
B,
C.
C. Okay. So I have got next class. Let us continue in the next session, please.
Yes,
Bye
sir.
bye, all of you.
Bye,
Thank you,
sir.
sir.
Thank you, sir. Thank you,
Thank
sir.
you, sir.